Types of lasers. There are several types of lasers. Based on the active medium, they are classified as solid state lasers, gas lasers, liquid lasers, and semiconductor lasers. RUBI laser and NDOAG lasers are solid state lasers. The example for gas lasers are CO2 laser, helium neon laser, and argon ion laser. Gallium arsenic laser and indium phosphorus laser are semiconductor laser. RUBI laser. A RUBI laser is a solid state laser that uses synthetic ruby crystal as its laser medium. RUBI laser is the first successful laser which is developed by Mainman in 1960. Construction of RUBI laser. The RUBI laser consists of three major components: the laser medium, that is active medium, the pumping source, and the optical resonator. A single crystal ruby in the form of a cylinder is used as the active medium. It is made up of aluminum oxide doped with chromium ions, and a helical xenon flash lamp is used as optical source. The active medium is placed inside this helical flash lamp. The third component is optical resonator. This optical resonator consists of two reflecting mirrors. One is partially silvered mirror, another is fully silvered mirror. Working of RUBI laser. The RUBI laser is a three-level laser in which three energy levels of the medium are involved in the laser action. During the optical pumping, the incident light photons supply energy to raise the atoms of the medium from the ground state E1 to the higher energy level E2, called pumping state. The state E3 is called pumping state. After a short period of time, that is 10 power minus 8 seconds, the excited atoms fall into the metastable state E2 by non-radiative transition. The lifetime of metastable state E2 is of the order of 10 power minus 3 seconds, which is very longer compared to that in the excited state. Before pumping, the number of atoms N1 in the ground state are greater than the number of atoms in the metastable state, whereas after pumping, the number of atoms in the metastable state are greater than the number of atoms in the ground state. Thus, the population inversion is achieved in the system by optical pumping. The laser action is started when any one of the excited atom returns back to the ground state from the metastable state by releasing a photon of energy h nu equal to E2 minus E1. This emission is called spontaneous emission. This emission occurs without any external agency or external force. When the emitted photon interacts with an atom in the metastable state, it forces that excited atom to fall into the ground state E1. As a result of this, another photon having the same energy is emitted. This is called stimulated emission because one photon induces an excited state to emit another photon. Therefore, this action is called stimulated emission. When these two emitted photons again interact with the metastable state atoms, two more atoms are de-excited and thereby two more photons are emitted by stimulated emission. These four photons in turn interact with four more excited atoms in the metastable state, and the chain reaction continues and an innumerable number of photons are emitted within a fraction of a second. These photons bounce back and forth between the two mirrors, and during this laser action, millions of photons are released with the same energy. Thus, the light is amplified and escapes through the partially reflecting mirror to produce laser light. Advantages of RUBI laser. RUBI laser is economical. The output power is not less as in the case of helium neon gas laser. Construction and function are simple and self-explanatory. There are some demerits in RUBI laser. The efficiency is comparatively low. The optical cavity of RUBI laser is short as compared to other lasers. There are several applications for RUBI laser. As it has low output power, it can be used in toys for children, used in schools, colleges, universities for science programs, used as decoration piece and artistic display.